Dear all, through this lecture we are going to start our module 5. The topic is two-port network parameters. Actually, this is a continuation of the network function topic that you have learned in module 4. That is why we are going to study about this through this lecture. So, which are the two-port network parameters? So, you know what do you mean by a two-port network and how the structure is organized. So the standard configuration of a two-port network is this. You will be having a rectangular block as a network, and you have the input current and voltage convention as I1 and V1, and output current and voltage convention as I2 and V2. So here in this figure, the port 1 dash or the port 1 is acting as the input port, and the port 2 dash formed by the terminal 2 and 2 dash is port 2, and that is acting as the output port. So this is the general or standard configuration of a two-port network. Now what do you mean by network parameters is that these are certain parameters that are going to characterize the properties of the network. Several parameters are there. 4 parameters are included in your syllabus. The first one is impedance parameters or Z parameter. So this is the first category, impedance parameter or Z parameter. These parameters are otherwise known as open circuit impedance parameters. Okay, Z parameters are otherwise known as open circuit impedance parameters, and through this parameter we are representing V1 and V2, that means the voltages, in terms of I1 and I2, that means the current. That means two voltages are represented in terms of currents. And second category is the admittance parameter, or in short Y parameter. Actual name of this is short circuit admittance parameters. Okay, so second category is short circuit admittance parameters, or simply admittance parameters, or in short Y parameters. You know that Y is the letter that is used for representing admittance, and Z is a letter that is used for representing impedance. That is why this is known as Z parameters, ratio between V and I, and this is known as Y parameters, ratio between I and V. Okay, so here the currents I1 and I2 are represented in terms of the voltages V1 and V2. Okay, and the third set of parameter is known as a transmission parameter or ABCD parameter. So the actual name is transmission parameter. In short, we can call it as ABCD parameter. Okay, here what is happening is the input voltage and input current V1 and I1 are represented in terms of the output voltage and output current V2 and I2. Okay, the input parameters are input quantities are represented in terms of output quantities. And the fourth category is the hybrid parameters, and here what is happening is the input voltage V1 and the output current I2 are represented in terms of input current I1 and output voltage V2. Okay, so input current, the input parameter V1 and output parameter I2 are represented in terms of the quantity I1 and V2. Okay, so these are the 4 important parameters that are included in your syllabus. We will study one by one. First, we are going to study about Z parameter. So, what do you mean by an Z parameter? So, Z parameter matrix is actually a 2 by 2 matrix that is consisting of 4 different parameters: Z11, Z12, Z21, and Z22. So, the equation representation of the Z parameter is V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 I2. So here the output and input and output voltages V1 and V2 are represented in terms of the input and output currents I1 and I2. And in matrix form, I can write the vector voltage vector V1 V2 is equal to the matrix Z matrix Z11 Z12 Z21 Z22 into the current vector I1 I2. Okay, so now how we can determine the values of Z11, Z12, Z21 and Z22 is that if you are open circuiting the input terminal, open circuiting input terminal means you are not connecting any load across the input terminal and that terminal is open. That means your I1 is equal to 0. Open means what? There is no current flow through that particular terminal. Okay, so if you are making your input port open circuited, then you will be getting the parameters. So from this equation, if I1 is equal to 0, I will be getting the parameters Z12 and Z22. Okay, so if I'm making I1 is equal to, in this equation I will be getting Z12 and Z22. And the second thing is, you can make the output port as open circuit. That means if the output port is open, means there is no current flow through that particular port, and that means I2 is equal to 0. If you are making I2 is equal to 0, you can find for Z11 and Z21. Okay, so this is the procedure for finding the values of Z12, Z22, Z11 and Z21. We are making either the input port open circuit or output port open circuit. That is why it is this parameter is known as open circuit impedance parameter. We are making any of the terminals open circuit for finding the ratio between voltage and current. Since the ratio is between voltage and current, that is known as impedance parameter. That is why open circuit impedance parameter. Okay. Now what is the name of it? What is the procedure is? First of all, we are making I1 as equal to 0. Okay, so if I am making I1 as equal to 0, what is happening is, from the first equation I can write V1 as equal to Z12 I2. Okay, and the second equation becomes V2 as equal to Z22 I2. So if I am making I1 as equal to 0, first equation changes to V1 is equal to Z12 I2, and second equation V2 is equal to Z22 I2. So from this I can solve for Z12 as what? V1 by I2, and Z22 as V2 by I2. So I am getting the ratios Z12 and Z22. Next thing is, I am making I2 is equal to 0. So when I am taking I2 is equal to 0, the first equation changes to V1 is equal to Z11 I1, and the second equation changes to V2 is equal to Z21 I1. So from the first equation I can solve for Z11 is equal to V1 by I1, and from the second equation I can solve for Z21 is equal to V2 by I1. Okay, so I am getting the parameter values. Z11 is equal to V1 by I1, 12 is equal to V1 by I2, 21 is equal to V2 by I1, and 22 is equal to V2 by I2. So the suffixes are actually giving the representation of the numerator and denominator. Okay, 2, 1 in this says that we have V2 by I1. Always Z will be the ratio between V and I. 2, 1 indicating that V2 and I1, and 1, 2 indicating that V1 and I2. So the designation will be like that. Okay. Now which all are the names of these parameters is that, here Z11 we know it is a ratio between V1 and I1. That is, it is a ratio between the input current and input voltage and input current. Therefore, it is known as open circuit input impedance. Okay, ratio between the voltage and current at the input port. Therefore, it is known as open circuit input impedance. And the second parameter is Z12. We know that it is a ratio between V1 and I2. That means due to the current in voltage in port 1 and due to the current in port 2, we will be getting the ratio Z12 is equal to V1 by I2, and therefore it is known as a open circuit transfer impedance from port 1 to port 2. Due to the voltage in port 1 and what is the variation in the current in port 2. So this is represented by Z12. That is it is known as open circuit transfer impedance from port 1 to port 2. And the third parameter is Z21, and it is known as open circuit transfer impedance from port 2 to port 1, because it is a ratio between V2 and I1. Okay, so what is the influence of V2 in the voltage connected in the port 2 in the current I1? So that is why it is known as open circuit transfer impedance from port 2 to port 1. And the last parameter is Z22, and it is a ratio between V2 and I2, and it is known as a open circuit output impedance, because it is a ratio of current and voltage at the output side. V2 by I1 at the output side, V2 by I2 at the output side, that is known as open circuit output impedance. So these are the names of the parameters. Next thing is how we can represent this parameters graphically, or what is the equivalent circuit, what is the equivalent circuit that is representing the two-port network. Equivalent circuit of a two-port network in terms of Z parameters. Okay, so I can write the equation as V1 is equal to Z11 I1 plus Z12 I2, and V2 is equal to Z21 I1 plus Z22 2 to I2. So you know that if input port quantities are input port, if you are taking, it is the voltage is V1 and current is I1. So I am taking the input port, I am having the current as I1 and the voltage that is connected to the input port is V1. Therefore I can represent the input port like this. Okay, so the first term is what? V1, first equation is V1 is equal to Z11 I1. So surely we will be having a impedance here that is represented as Z1. So I am getting the first term as Z11 I1. Next is actually Z12 I2. We know that Z12 is an impedance and I2 is a current. So impedance into current, it is a voltage that is depending upon the parameter I2. Okay, so that is it. That can be represented as a dependent source that is delivering a voltage equivalent to Z12 I2. So this is the representation of the input port. So I am repeating, the first term can be obtained by multiplying Z11 with I1 and the second term is also representing a voltage, but it is depending upon the current at the output side. So I can represent that quantity, that means Z12 I2 as a dependent voltage source that is delivering voltage equivalent to Z12 I2. So this is actually the first equation. Then the second equation is, I am taking the second port. This is the second port and port 2, and here the voltage is V2 and the current is I2. And the second term that is representing Z22 I2 is, I2 is there. So if I am having an impedance that is having the impedance equivalent to Z22, I will be getting the voltage Z22 into I2 this term. Then what about the first term is? The first term is Z21 into I1, that is depending on the current at the input side, current at the port 1. Therefore, this parameter can be considered as a dependent voltage source that is delivering a voltage equivalent to Z21 I1, where I1 is the current at the port 1. Okay, so here also I can represent this as a dependent source that is delivering a voltage equivalent to Z21 I1, and here you have the equation. So this much portion is representing equation 1 and this much portion is representing equation 2. Okay, so this is the equivalent circuit of a two-port network or equivalent network of a two-port network in terms of Z parameters. Okay, so that's all with Z parameters. Thank you.